We're ready for our next talk. We're going to be hearing from Brian Hayden from Space Telescope Science Institute, and he will talk about calibrating Hubble data in the commercial cloud.
Yes, thank you. So I'm going to talk today about a project at Space Telescope to move the Hubble production data processing pipeline into AWS. So I'm just going to first lay a little bit of background so we're on the same page about how much data we have and how we currently manage data processing on-premise. And then I'm going to talk you through the migration process that we've been going through and how we went from research to prototype to actually getting things into production. So to start with, here's some stats that I compiled on our on-prem data processing jobs. There's about 460,000 unique data sets that could at any one time be reprocessed if we have new reference files or code that would demand so. Those jobs on premise take about 100,000 CPU hours. The thing that I want to note here is the very long-tailed distribution to memory usage and wall clock time. So the jobs on average are pretty pedestrian, I would say, but really big data sets have a very long tail to high resource usage, and that can be challenging for avoiding over or underutilization of resources on the cloud. So on premise, we accomplished this with an HT Condor based workflow management system. So we have one primary machine with 80 cores. That's a physical machine. 20 of those cores are allocated to sort of bookkeeping and housekeeping work for the primary archive and other things like that. 60 of those cores are allocated for data processing. And then we have 35 virtual machines with 8 cores and 64 gigabytes of memory each, for a total of 340 cores, constantly always allocated to data processing, but not always utilized. So if we're not doing a big reprocessing run, those cores sit idle a lot. Each VM has a Conda environment with a calibration software on it. The on-premise workflows are very database reliant for the archive. And so roughly speaking, just the hardware for all these VMs and whatnot is about 550,000 per 5 years. So if you assume the equivalent of a full reprocessing run 3 to 5 times per year, that makes a repro run take about $22,000 to $36,000. So there's been a big push at Space Telescope to investigate and move things to the cloud. And so the Director's Discretionary Research Fund funded a project to investigate moving HST into the cloud. And so the high-level goals of this project were to build a proof of concept data processing system that would reduce costs via lower developer and operator time and also cheaper hardware. And separately, though I'm not going to talk about it today, investigate cloud-based machine learning applications to produce new and better scientific products. DMD is broken down into Scrum teams, and the Scrum team Octarine is the cloud-based infrastructure team, which is the team that I'm on. And we were already at the time working on a workflow manager technical report for Roman. And we had narrowed down our cloud-based workflow managers to basically the ones we preferred were AWS Batch, HT Condor with this Condor Annex process that puts EC2 instances into the pool, and then Apache Airflow. And the decision really comes down to whether you want AWS to manage your infrastructure for you, or if you want to have some control over that and the possible increased costs that entails in human costs. And so for this project, the best solution was really AWS Batch, as that got us into cloud managed, AWS managed services. So at the time that we started implementing this, all members of the team had basically had 30 to 40 hours of AWS training spread across in-person workshops and online courses. A couple members of the team had some prior AWS experience, although they didn't really work on this prototype very much. So most of the prototype was done with people who were sort of building their first cloud-based application. So in a single 2-week sprint, we implemented an AWS batch prototype that processed 10,000 data sets. And we projected the cost from that it would be about $10,000 per full repro run. So compared to the 22 to 36,000 that I told you earlier for on-prem. So a quick outline of what the infrastructure looks like for that prototype. So AWS batch is sort of the brains of the operation, and then Amazon Elastic Container Service and Elastic Container Registry, ECS and ECR, are sort of the nervous system in the sense that they are where all the work actually happens. So there's a Docker container that has our calibration code and everything installed on it. And ECS will acquire EC2 resources through an auto-scaling group in order to basically launch those containers and do the data processing. For the prototype, in each container, we were retrieving files from STScI through Astro Query. And then the output of the cal code, standard out and standard error, is streamed to CloudWatch, and the actual calibrated data files are dumped into an S3 bucket. After we presented this prototype to the mission office, the HST mission office and the data science mission office, they asked us to move reprocessing into the cloud and eventually try to move all of HST data management subsystem into the cloud. So this is just a quick comparison of sort of the pros and cons of on-prem versus AWS batch, but the big hardware cost savings, as I see it, is in the fact that when it's the pay-as-you-go model, right? So when we're not using the AWS system, it racks up almost no costs except for some little storage costs for S3 and things like that. So we're only paying for compute when we need it. And then, of course, the managed services offload infrastructure costs to AWS. So, nobody from STScI has to get up at 3 o'clock in the morning on Saturday night and go fix something in the data center and things like that. So
5 minutes.
Thanks. We expect that there's a big ramp up cost in migrating to AWS, but ultimately it should reduce development operations and hardware costs due to improved reliability and the pay-as-you-go cost structure. So I'm going to probably be done a little bit early, so I have just 2 more slides. But the first phase is to move just the data reprocessing into AWS, and so we're proceeding with that right now. The challenges that we face, as I see it, are CI/CD. So infrastructure as code is sort of it's not new for us, but having this much control over the hardware that you are allocated is a little bit new, because typically our IT division would do that for the on-premise hardware. Data transfer is a big challenge, both in rates and also in cost, because for this first system, we're moving a bunch of stuff up and then calibrating it and then moving it back down. Communication in the hybrid system between the on-premise system and the on AWS application, we're trying to avoid any need for the AWS system to penetrate into the STScI network, because there's a big security overhead in making sure that everything is as safe as possible there. So for instance, of trying to avoid database access from the cloud-based processes. Handling the disparity in job requirements that I mentioned earlier in order to be efficient with our compute usage. And then just training people. I mean, we've been operating HST DMS for decades on premise. And so there's just a big sort of change in mentality here. So the final things I want to know are just our GitHub repos, where most of the work is visible to you if you'd like to look at it. So the CalDP package has the Docker file for how we build the Docker image that's in the container registry. And it's got a Python wrapper around the actual calibration code in a Conda environment. this is intended for public usage, although at the moment it's maybe not so user-friendly. It's still in active development. And then the Cal Cloud repo is where our, for instance, our Terraform scripts for CI/CD for building the AWS infrastructure are, and some other utilities that we use, like a Lambda function that can submit batch jobs if we want to go that route, and an API gateway associated with it, and things like that. So these are still pretty early in the process, but feel free to start using them. If you start using CalDP, for instance, to process Hubble data if you want, and leave us issues on the GitHub, and we'll address them as we can. So that's all, and thank you.
Thank you very much. Okay, so we actually have some questions.
Ready? First off was Christoph asks, how long does a repro take on AWS compared to on-prem?
Yes, I forgot to mention that. So on-prem, a big reprocessing run, especially of like WIFC3 UViz or ACS, which have CTE corrections in them, those can take weeks, 3 to 4 weeks. Whereas on the cloud, it can take kind of as long as we would like it to take, because we can scale as parallel. We can basically, do as many simultaneous jobs as we want by just allocating more CPUs in the pool that AWS batch is allowed to draw from. So that's one of the big bonuses for the mission offices, is the reduced wall clock time for less compute cost even. So.
Okay, we had a question from Peter regarding compute when you need it. He asks, how do you sleep or turn off the machines? They can be very expensive if they are idle. So
batch.
Yeah,
oh,
go
sorry.
Ahead, sorry. No,
I was going to say the Elastic Container Service and the auto scaling group do that automatically. So effectively, AWS Batch looks at the number of jobs it has in its pool that need processed, and it sets a desired number of CPUs in the scaling group. And so it turns them on. ECS turns those EC2s on as it needs them, and then as the jobs drain out of the pool, it turns them off when it doesn't need them anymore.
Okay. We have a question from Danielle. He's asking if you will do the same for JWST.
It'll be years if we do. I mean, so we're pretty locked in to the software as it stands now, because we can't tinker with it at this level before this close to launch and commissioning. So I don't know the answer to that.
Okay, we have a couple of questions I'm going to kind of combine. Well, they're all related to cost, so I'll just ask them all together. So one of the questions is, does the $10,000 cost for reprocessing include data transfer, ST to AWS, and then from AWS back to ST?
So I actually am not totally sure about that. I think so. The transfer from ST to AWS is not going to be very much. They don't charge you much to bring data in. They charge you to get it out. And so I do think that some of the egress cost is missing from that 10,000 per repro. But we're actively working with IT and with our AWS enterprise agreement to make sure that the egress costs back to ST are as cheap as possible. So I think the 10,000 underestimates the transfer costs back.
Okay, next question is, they're asking if maintenance staff is or will be fired, or if the cost reduction is solely effectuated by not having to buy new hardware every 5 years.
This is a common question. So that the cost that I gave you did not include labor costs. That was only the cost of rotating that amount of hardware every 5 years. So this is common. I don't really know how people handle it. I do know that like the type of work that's needed, it's not necessarily a whole lot less work, but it's different kind of work. So like IT has shifted a lot to how to manage the security in the cloud and how to help us set up like IAM roles and VPCs and networking stuff to be as safe as possible. So, you know, at least in the ramp up, there's about the same amount of human time needed. I guess I don't really know how to answer the long-term maintenance staff situation.
Okay, and then there are a lot of questions. Unfortunately, we don't have time to answer them all. So just the last question, and then maybe you guys can ask on Discord, the people who'd asked in the QA, if you could ask again on Discord, and maybe Brian can answer there. But the last question that we have time for was also cost related. Do the cost includes the staff training that you had mentioned for AWS?
No, not really. I mean, so the cost that I was quoting was more of what we think the sort of long-term operational costs are, and it doesn't include the ramp-up costs. But in a lot of ways, I think the Institute is sort of paying for training in the sense that they're heavily prioritizing it for all the groups. So I guess that's about it.
Okay, thank you again.